All right, so I want to welcome you to today's session. Today's class is going to be a continuation of yesterday's class, what we looked at. We're going to be continuing from where we stopped on the concept of access control list. And in access control list, what we studied was that it is the rule-based security system where you filter which system accesses certain resources, or you create a permit and deny rule that actually grants privileges to systems. All right. So basically, we're going to continue from there. In the last class, we were able to stop at named standard access list. So we will continue from there where we stopped. Now we're going to continue on the numbered extended access list. We have looked at the named access list. This is where we looked at the numbered extended access list. This is where we stopped yesterday. So today we'll be looking at a continuation of the numbered extended access list. Now, in the numbered extended access list, there are certain elements that we are going to be talking about that are going to be noted. For instance, we're going to be talking about the access list number. Okay, and the access list decimal number extended range from 100 to 199, or from 2000 to 2699, right? Then there's also going to be the deny command. This denies access if the condition is matched. We'll talk about the permit. This permits access if the condition is reached. We'll talk about the remark. Adds a text entry for documentation purposes. We'll talk about the protocol. You see, in the standard access list, we didn't talk about the protocol. Okay, but in the extended, we'll talk about the protocol. Remember, for the standard, we say it runs on layer 3 of the OSI model, which is the network layer. But the extended runs on both layer 3 and layer 4. All right. Then we talked about the source address, which is the source IP address. We talked about the wildcard mask, which we said is the inverse of the subnet mask. It's a 32-bit wildcard mask that applies to the source address. We talked about the destination address and the wildcard mask, the operator, the port, which is optional, and then there's establish and log. These are the elements that are required when it comes to extended access list. So when we talked about port numbers, we said that it runs on transport layer. Okay, so in the transport layer, the system that is generating the traffic has a source port number. The system that the target system, which is the server which you're trying to access, has what they call the destination port number. All right. So extended access list can filter many different types of internet protocol and ports. So the applications that you want to permit or deny runs on the port that we're going to be talking about. So the 4 highlighted protocols, as you can see, are the most popular ones. That is the ICMP. ICMP is the one for ping. All right, whether you run a ping or you run traceroute or traceroute or things like that. Okay, then there's another one for IP addressing. Okay, then there's another one coming good for TCP IP. That's for transmission control protocol. And then for UDP, which is the user datagram protocol. So selecting protocol influences port numbers. For instance, if you are using DNS, DNS runs on port number 53. It's a popular port, so we should all know. If you are using FTP, FTP runs on port number 21. Okay. Now, there are so many other services and the port numbers they give. Why we selected these ones are mostly the most frequent one. FTP data runs on port 20. Okay. So extended access list can filter on different port numbers and port name. So the example configures an extended access list 100 to filter HTTP traffic. HTTP is like a web traffic. Okay, so HTTP is the protocol that manages web traffic. So in this kind of access list, how you filter is using the port number. So what is then the port number for HTTP? Most of the times you either use www or you use the port number 80. So if you use www or you use 80, you will get the same result. So this is an example. Access list 100 and then permit, then you see TCP, which is the transport protocol. Any, that means the source address. Okay, this is the source address. This is the subnet mask. Okay, so permit any, that is any IP address with any subnet mask that equates to www. It's the same thing here. Permit any that equates to 80. What we're saying in this command is that you are permitting HTTP, any IP address on the network that is browsing the internet, it wants to go to the internet, is permitted. That's what it's saying. All right. Now, how about when you're configuring the port number that is required when there is not a specific protocol name listed, such as SSH or HTTPS. SSH is the protocol you use when you want to remotely log into a system, right? And then HTTPS is HTTP secure. All right, so SSH runs on port 22, HTTPS runs on port 443. So I say access list 100, that means it's an extended access list. And I'm saying it should permit then TCP, which is a transport layer, any IP address with any subnet mask that is going to, or that is tagged for SSH, that is using SSH. So any system that is using SSH to connect to anywhere is permitted. At the same time, access list 100 permit TCP any IP address with any subnet mask and is going to 443. That means he wants to browse HTTP secure, is permitted. Okay, so TCP establish extended access list. TCP can perform basic stateful firewall services using the TCP established keyword that enables inside traffic to exit the inside private network and permits the returning reply traffic to enter inside the private network. TCP traffic generated by an outside host and attempting to communicate with an inside host is denied. The established keyword can be used to permit only the return HTTP traffic from the requested website. So while denying all other traffic. So the topology shows access list 110 previously configured that will filter traffic from the inside private network. Okay. And then access list 120 using the established keyword will filter traffic coming into the inside private network. So this is what we're talking about. This is the outside public network. Invariably, that's the internet. Okay. This is the inside private network. Invariably, that is our local area network. That is our LAN. Now, this is our edge router. The edge router is the router that sits in between your public network and your private network. That's your edge router. Now, as it is now, we need to create an access list for traffic that is coming into the local area network or into the private network, and then access list that is taking traffic going outside. All right. And that's why you see it here. The one coming into, this is the one with access list number 120, and it's configured on router 1, okay? And it will be applied on this interface. The one going outside, okay, is also configured on router 1 and will also be applied on this interface. So we will see. So this is the configuration, right? So access list 120 to only permit the returning web traffic to inside host and then applied inbound on router 1. So you see, this is access list 120 permit TCP any IP address. Is that not so? TCP with any IP address going to this destination with this wildcard mask, okay? And it's established. And then you go to the interface G0/0. Look at it here. This is the interface G0/0. And then you say IP access group 120 out. That is what you have done. Okay, that's what you have done. So here, if you use the show access list command, it displays all the access lists that have been configured. Now, the one that we just did here is 120. But once you use the show access list command, it shows you in this router, there's an access list 10 that has been configured. And what is it doing? Permitting TCP and the IP address on this block with this wildcard mask going anywhere. If they are going anywhere, they should be, and they are browsing, they should be permitted. That's what this is saying. And then there is another one, IP address access list 20, permit TCP, the same IP block going anywhere, and is browsing with HTTP secure, it should be permitted. Okay. And then see the extended access list. Then okay, access list 120 here. So this one is what applies to it. So the established parameter allows only responses to the traffic that originates from this network to return back to the network. That is why the established this thing is used. Named extended access list. So you see in the numbered, we were using numbers to identify. Now in the named one, to create a name extended access list, use the following global configuration command. In the router mode, you say IP access list extended. Then you give the access list name. This command enters the name extended configuration mode. Recall that access list names are alphanumeric, case sensitive, and must be unique. In the example, a name extended access list called no FTP access is created and prompted to change to name extended access list configuration mode. Okay, so this is it. So you see IP access list extended, and then this is the name that was created. Okay, so this is the example, and it's a similar example for what we did. So a name extended access list are created in essentially the same way that a numbered access lists are created. The topology demonstrates configuring and applying two name extended access lists to an interface. All right, this is the interface that they are applied to. So for surfing, this will permit inside HTTP traffic to exit normal internet. That is all the traffic on this network. As they are going out, they are permitted, okay? And then browsing, this will permit only returning web traffic to the inside host, while the other traffic existing router 1 interface are implicitly denied. What are we saying? You see, the traffic that goes out here, they are to come back again. They are to come back. So They are saying that only the traffic that has been permitted here to go out are the traffic that are called established. Okay? Those are the traffic that are established. So they have been tagged, established. They are the only ones that will go and come back, which means any traffic that is generating from elsewhere that wants to come back should not be allowed. Any traffic generated from elsewhere that wants to come back should not be allowed. So the surfing access list statement permits HTTP and HTTPS traffic from inside users to exit the interface connected to the internet. Web traffic returning from the internet is permitted back into the inside private network by browsing the access list. So these are the commands for the surfing. When we say surfing, that is from inside network, you're going outside. From inside the network, you're going outside. And then you say browsing from outside is coming in. So it says remark permits inside HTTP, HTTPS traffic. How do you permit it? So you permit then the IP block going to any destination for the 80. 80 means it's browsing, right? The same thing, 443, that means browsing securely, right? So it's permitted, and then it's exited. Then access list extended for browsing. Browsing now, we are looking at the traffic that is coming back into the network, all right? And we said, look at the remark, only traffic returning HTTP or HTTPS. So how do you ensure that only the traffic that have been permitted to go out are the ones that are to come back? By using the keyword established here. That's all. Once you use the keyword established, you are good. After that, you go to the interface and then IP access group in and then IP access group out. And that is all. Once you've done that, you have done that. So this is the syntax. 2 methods to modify the access list. After an access list is configured, it may be modified in case you made a mistake or in case your traffic changes or there is a different policy in the organization you want to change. So access lists with multiple access control entries can be complex to configure. So sometimes the configured access list does not yield the expected behavior. So for these reasons, access control list may initially require a bit of trial and error to achieve the desired filtering, right? The filtering result. So this section will discuss 2 methods to use when modifying an access list. So one is to use a text editor like Notepad. Just copy it, take it to Notepad and edit it. And then other is to use sequence number. Now, using the editor, access list with multiple access control entries should be created in a text editor. This allows you to plan the required access control entries, create the access control list, and then paste it into the router interface. It also simplifies the task to edit and fix the access control list. So for example, access list 1 was entered incorrectly using 19 instead of 192 for the first octet as is shown. So you see, for instance, I put access list 1 deny, instead of 192, they are putting 19. All right, so that's an error. That's an error. And 19 is a valid IP address. It's a valid IP address. So what do you do in this particular case? You will have to make corrections. Okay, you have to make the corrections. So the first access control entry should have been to deny the host at this, but it was wrongly entered. So you can just copy it and take it. So to correct the error, just copy the access control from the beginning of the configuration and paste it on the editor. Make the necessary changes as you want. Then remove the already configured access list on the router by using the no access list command. Can you see? So you just use the no access list command. It will remove that one. So once it removes it, then you now repaste the one that you have copied from the editor, and that's all. Now, the other method is by using sequence number method. So an access control list entries can also be deleted by using an access control list sequence numbers. Sequence numbers are automatically assigned when the access control entries is entered. Okay, because we said access list run sequentially. So it gives them sequence number. So these numbers are listed in the show access list command. The show running config command does not display the sequence numbers. All right, so that is it. So still on the sequence number, all you just need to do is change the sequence number, which means you can just say no to a particular command. For instance, now, if you see this two access control list, this is access list 10 is to deny, 20 is to permit. All right, so what you need to do is once you say no 10, you are trying to remove 10 or you want to alter it or edit it, and that is all. How about implementing access lists? Access control list configuration guidelines. When configuring and applying access list, be aware of the guidelines that we have summarized here. 1, create an access list globally, then apply it. When you say globally, you are thinking about how it affects the router in its entirety. And that's why when you are configuring, you configure it in what we call the global configuration mode. Okay? Ensure the last statement is an implicit deny any or deny IP any. Yeah? After you've written everything, then you say deny any other. So you mostly do your permission, deny what you want to deny, permit what you want to deny, but there's an implicit deny. So statements order is important because access control lists are processed from top to down. So the order in which you write it matters a lot. So if you check even the firewall of your routers, go to your firewall of your routers, how the order in which they are arranged matters a lot. So as soon as a statement is matched, the access list is exited. So always filter from the most specific to the most generic. From the most specific to the most generic. So that's how it works. Only one access list is allowed per interface, per protocol, per direction. Very important. Per interface, per protocol, per direction. New statements for an existing access list are added to both to the bottom of the access list by default. So router generated packets are not filtered by outbound access list. All right, so place standard access list. This is very important. These two you see here, don't forget them. Place standard access list close to destination as possible. Close to destination as possible. Place extended access close to source as much as possible. All right. So, for instance, let's look at this. If I am having an access control list that is saying is a standard access list, remember, standard access list is close to destination. And we're saying no access, right? So deny host 192.168.11.10. Where is 192.168.11.10? So we are denying this host. We're denying this host. And then we're permitting any. So look at it here. When you are applying it, where are you applying it? Interface G0/0. Where is G0/0? Look at it here. You are denying this host access to maybe this one or any resources on this network. And remember, standard access lists are applied close to what? Destination. That is very key. So if it was an extended access list, we're going to place it close to source, which means we're going to place it here. Okay, so this is for extended, this is for standard. Okay, so okay, every access list should be placed where it is going to be most efficient. So assuming the objective is to prevent traffic that originates from 10.0 network from reaching 10.30 network. So where is 10.30? Where is 10.0? This is 10.0 network. And this is 10.30 network. So if, for instance, I'm using an extended access list, is going to be close to the source. Extended access list should be close to the source as possible. So 10.0 to prevent it from going to 10.30, what do? This is close to the source. This is your source here. Okay? But if you want to look at standard access list close to the destination, this is going to be close to the destination. So that is it. So you see, for standard access list should be close to the destination as possible. All right, so placement of access list and therefore the type of access list used may depend on a variety of factors as we have. All right, the extent of organizational control, the bandwidth of the network involved, and then the ease of configuration. So we have, this is still talking about placement. Let's look at it. Where are we looking at it? So we are looking at the same 10.0 network from accessing 10.30. Two possible interfaces to apply standard access list. So the standard access list are close to destination. Is that not so? And this is the 10.0 network. This is 10.30. Where is the destination router? This is the destination router here. So what is saying that you can apply it this way, inbound or outbound. This is inbound or this is outbound. Okay, so if applied this way, if it's applied inbound, if applied this way to deny traffic from the .10 network, it will also filter .10 traffic to the 10.31, which means if you apply it here, it will drop the traffic from here from even accessing this guy here. It will not allow you to access them. So the best way is to put it here. So you put it outbound. So we have a packet tracer activity we are going to do. So still a packet tracer activity we're going to do. Packet tracer. This is the last part, and then we will go into our packet tracer activities. Okay. Sorry. Okay, mitigate attacks with access lists. Access lists can be used to mitigate many network threats such as IP address spoofing, denial of service attack. Most DOS attacks use some type of spoofing. So if IP address spoofing overrides the normal packet creation process by inserting a common IP header with a different source IP address, attackers can hide their identity by spoofing the source IP address. There are many well-known classes of IP addresses that should never be seen as source IP address for traffic entering and network organizations. Okay, so look at this for instance. The S000 interface, which is this guy that is connected to the internet, should never accept inbound traffic from the internet. Okay, should never accept traffic from all the 0 addresses or broadcasts from this. So, which means when you are configuring your router or your firewall, one of the statements you're going to put is to block traffic that are inbound that have this block of IP addresses or this block of IP addresses. Okay. Then the 192.168.1.0 network is attached to the R1G0 interface. That is this IP address here. That should only be inbound traffic packet with source address from the network. That is why we talked about the established. So if the traffic is established, it can go out and come in. All right. So the access control list shown in the figure will only permit inbound traffic from this particular network. So that is very, very key. Okay. Permit necessary traffic through a firewall. So an effective strategy for mitigating attacks, explicit permit only contains types of traffic through a firewall. DNS, SMTP, FTP are services that often must be allowed through a firewall. Configure a firewall so that it permits administrators to remote access through a firewall. SSH, syslogs, SNMP are examples of services that a router may need to include. So while many of these services are useful, they should be controlled and monitored. Exploitation of these services may lead to security vulnerability. So example of this topology, as you can see here, is with access list that permits specific services through this guy. So this is my router, and this is my DMZ, where my servers are. This guy is on the internet, right? And we are permitting specific services. So we go for our access, since it's specific services, is transport layer or application layer, because I have to use port number or protocol port number. So it's going to be an extended access list. So you see here, access list 100, permit UDP, because DNS, for instance, runs on UDP. So the service you want to permit or deny, you need to know whether it runs on TCP or UDP. So DNS, for instance, run on UDP. And it says permit UDP from any, so it's usually source and then destination. So from any source with a host, any source and a host, any source to this host here. What is this host? 20.2. 20.2 is this server. So you see this server, we have configured it for DNS. So we are permitting any traffic to reach to this DNS. That's what that one is saying. The second one, access list 180, still extended. Permit TCP. Now, TCP is one of the other services, FTP. Okay? So, or SMTP. All right? SMTP. So, permit TCP from any host, from anybody accessing this host address. And the protocol is what? SMTP. Permit it. The first one, the protocol is domain, which is DNS. The third one, the protocol is FTP. And FTP is also TCP. All right, so permit any IP address coming to this host that is related to FTP. Then the next one, TCP permitting this public address to also FTP, then to syslog, and then to SMTP trap. So that is how you can use access lists to permit. So we're going to do the lab activities on it, okay? So all these are part of it. So mitigating SNMP. SNMP is a protocol that you use when you want to manage your other devices, your network devices, maybe your access points, your routers, your servers, your switches. You want to centrally manage them to know when they are up, when they are down, to know whether the CPU is working well, the RAM, the storage, and things like that. That's where you use SNMP, okay? So sometimes it can create vulnerability. So management protocol are useful for remote monitoring and management of network devices, but they can still be exploited. So if SNMP is necessary, exploitation of SNMP vulnerabilities can be mitigated by applying interface access lists to filter SNMP packets from non-authorized systems. So an exploit may still be possible if the SNMP packet is sourced from an address that has been spoofed and is permitted by the access list. So the most effective means of exploitation prevention is to disable the SNMP server on the iOS devices for which it is not required. If it is required, enable it. If it is not required, disable it on those particular routers or switches on those devices. Okay? So how do you disable it? Go to your global configuration mode and type no SNMP-server and it will disable it. Why do you need to disable it if you are not using it? Because if you leave it open, it will be vulnerable. It's like Bluetooth of your phone. If you are not using the Bluetooth of your phone, always put it off. If you leave it open and you are not using it, somebody can now connect through it. So we have access packet tracers. Okay. IP version 6 access control list overview. Everything that we have done for IP version 4 can also be done for IP version 6. I know some of you are new to this concept of IP addressing, especially IP version 6. You have not fully understood IP version 4. Now you're going to IP version 6. I am doing a video tutorial on general networking basics. And during this video tutorial, I'm going to cover extensively IP addressing, both IP version 4 and then IP version 6. Okay, so you may wish to check. So just when you go to the YouTube channel, you also see it over there. All right, so we're saying IP version 4 will coexist with IP version 6 and then gradually be replaced by IP version 6. An example of a securities concern is threat actors leveraging IP version 4 to exploit IP version 6 in dual stack environments. In a dual stack environment, devices operate with both IP version 4 and version 6. Threat actors can accomplish stealth attack that result in trust exploitation by using a dual stack host. So rogue NDPs, neighbor discovery protocols, that's the NDP, all right? So the point we're making here is that IP version 6 is important, but usually in some organizations, you run both the IP version 4 and you run it with the IP version 6. So if you are not using any, somebody can take advantage of that, okay? So threat actors can compromise additional hosts before sending traffic back to the network, as you can see here, right? So, which means that this is the firewall that prevents, and this firewall is IP version 4 firewall sees and allows UDP traffic. But what will the threat actor do? The threat actor traffic will infect a particular system, and the system will now be authenticated by this guy, by the firewall before then it's been permitted. Okay, so unknown IP version 6 hosts automatically their stacks silently by initiating automatic thread tunnel using UDP. So it is necessary to actually develop and implement a strategy to prevent attack against IP version 6. So this mitigation strategy should include filtering at the edge using various techniques such as IP version 6 IPS. So this is the syntax for configuring access list in version 6. It's the same thing. You see in version 4, you just say access list, then the access list name. In version 6, all you just need to do is just put IPv6. Okay, IPv6. If you put IPv6, then you are good. Every other thing still remains the same. So if you look at configuring it, everything you do where you put IP, you will put IP version 6. All right. So if you put IP version 6 access list, this, every other thing will now go the same way that you talk. Another thing that differs when you are saying permit, when you are putting the IP address, instead of subnet mask for IP version 6, you will use the slash notation. Okay. I think basically that is it. So, all right. So I think we have come to the end of chapter 4. So we're going to launch maybe a packet tracer. Let me do that. Just a minute. Packet tracer, let me put extended access lists. All right, it's loading. It's loading. Okay, it's loading. All right, so let me stop sharing this one. Share that one. Share that one. Okay. All right, so this is the activity. Packet tracer extended access list, scenario 1. There's another one for scenario 2. So for this first scenario 1, the objective of this activity, let me do it this way. So let me just share my screen here. Okay. So the objective, as you can see, is to configure, apply, and verify extended numbered access lists. And then that's for part 1. And part 2, configure, apply, and verify an extended named access lists. Okay. All right. So the background says 2 employees need access to services provided by the server. Okay. PC1 only needs FTP access. PC2 only need web access. So where this is PC1 can only need FTP and PC2 can only need web. Okay. But both computers need to be able to ping the server, but not reach the other. All right, so we're going to be using extended. So instructions, part 1, configure and apply verified extended numbered access list. So how do we do that? We will configure an access list to permit FTP and ICMP from PC1 LAN. All right, so from that, we will go to the global configuration mode on router 1. And then we enter the following commands to determine the first valid numbers of an extended access list. So this is router 1. Right? So good. So I'm going to enter enable, then configure terminal. Sorry. Config terminal. Now, we're going to now configure our access list. And you see the idea of the question mark, assuming we don't know what to do. So it's called context sensitive help. So if I type access list, if I put a question mark, I don't know. It will tell me, am I doing standard or am I doing extended? If I'm doing standard, it's between 1 to 99. If I'm doing extended, 100 to 199. Okay? And then from what we are doing is extended. All right? That's what the activity asks us to do. So it says add 100 to the command followed by a question mark. So we will do that and then follow. So if we say 100, since it's an extended, and then we put a question mark. So it will ask us, do we want to deny or do we want to permit or do we just want to put a remark for documentation? Okay. So remember, we have FTP. We're supposed to permit it to do FTP, right? So to permit FTP traffic, we need to enter permit followed by the question mark. So if I say permit, I put a question mark. So you see, where is the permit? This is permit and a question mark. Look at the protocols it has brought out for me. We can permit EIGRP, ESP, AHP, ICMP, IP, OSPF, TCP, UDP. We can permit all this. All right. That is what we have here. So that is it. So permits this. So our concern is FTP is using what? TCP. All right. So we can say permit TCP. Now it's telling us what is the source address. If we have source address, we put it. But if we want to permit any other person, we just put this. If you want to permit a single host, we will put this. But let's see what the activity asks us to do. Okay. So permit TCP. Yes. Okay. So permit TCP, we are to enter the IP address 172.22.34.64. All right. That is the IP address we are to enter. So let's do that. Now let's check the table. What is this IP address? 34.64. The 64 is the network address. So is the network address, let's see. This is PC1, desktop, IP configuration. Good. This is the private IP address for PC1. This is the default gateway. So the 64 is going to be what we call the network address. Okay. So which means it's going to be an address. Can you see it here? 34.64. You see, so it's going to be the address that will cover all the systems that are going to be connected here. Okay. So let's say permit TCP 172.22.34.64. So we're supposed to enter the wildcard mask. since we don't have a subnet mask. Okay, so if I put a question mark, look at it. So it's expecting the wildcard mask. Now, for us to know the wildcard mask, we need to know the subnet mask. Now, what is the subnet mask? The subnet mask is /27. Look at it. Here, they are giving us /27. /27, what is the subnet mask? Look at it here. Now, if you just subtract all this from 255, so let's say, let me just use my calculator to make it fast. So if I say 255 minus 224, I should be able to get 31. 255 minus 224. You see? So I'm able to get 31 here, right? So that is my wildcard mask, 0.0.0.31. Okay? That's what we've gotten here, right? So the wildcard mask of the source. So 0.0.0.31 of the source. The next thing now is destination. So you see, we have put access list 100, permit TCP, then the source address. Yeah. So we are permitted where to go to destination. So if I put a question mark, it will now ask me destination address. Yeah. If there is a particular destination, I will specify the IP address. But if it doesn't matter any destination, I'll just put any. If I put any, that is any destination host. Okay. So access list 100, permit TCP, this. Then you see now they're using the command host before this IP address. Why is it so? The first one, they didn't use host because they're using a network address. But this one, they're using host, so they are not going to use the /26. This is the network address, but they are going to use the IP address of the server. Look at it, 34.62. This is the IP address. Okay, so I'm going to now put hosts. Okay, and then 172.122.22.34.62. Okay, .62. Right, so host this. So after that, what next? Now, there are areas of specification. All right, the protocol that we are interested in. You see, that is where we ask you equals what? EQ means equals. All right, so EQ, if I put a question mark, then it will give me the options of the protocols, whether FTP or POP3 or SMTP or Telnet or www. So in this particular case, it's supposed to be what? FTP. So FTP, or we can put port 21 if we so wish, but we'll put FTP. Right? Now, if I put a question mark, these are the options. Establish precedence and then DSCP. Or we can just put it to an end. Can you see? This one means we can even end it there. So let's find out from the activity, do they need any other thing? They say they don't need any other thing. So we can end it from there. So from here, we can just press enter. Okay? We can just press enter. So this is the command access lists. 100 means that it is an extended access list, and it is, what do they call it now? It is a numbered access list. And then we're saying permits. Oh, okay. There's another one. So we have done for FTP. So we're going to do another one here. It says create a second access list statement to permit ICMP, which is ping traffic from PC1 server. Note that the access list number remains the same and the specific type ICMP traffic does not need to be specified. Okay, so let's do it. So we say access lists 100. So we're using 100 the same as the other one, so that when we come to apply to the interface, it will be IP access group 100. So IP access 100, then we say permits ICMP. All right, and then we specify the source addresses 172.22.34.64. The wildcard mask, we have done that before, 0.0.0.31. And then where we say host, because we want to talk about the specific destination, 172.22.34.62. All right, and then we press enter. So we have two access lists. Let's see the first one. This is the first one. Where is it that we have done? Okay, can you see? Access list 100, permit TCP 172.22.34.64 with the wildcard mask 000.31. And then going to host 172.22.34.62 equals FTP, right? Then the second one is this one. Look at it here. Access list 100, permit ICMP. Permit ICMP 172.22.34.64. Go with its wildcard mask of 0.0.0.31 to a host of 172.22.34.62. All right. So it says all other traffic will be denied. That is why we said it always have an implicit deny. Now, I says execute the show access list command and verify that access list 100 contains the correct statement, which we just did that. But for clarity's sake, you can just say show access lists, okay? Right? Show access list. So this is our access list. Our access list, what? 100. And it's an extended access list. So this is it. This is it. Okay. Now we need to apply it to the correct interface. And we say from router 1's perspective, all the traffic that access list 100 applies to is inbound from the network connected to gigabit 0/0. Okay. Now, this is the router. This is this guy. This is the destination. Now, we are saying if you are doing access list, if it is standard access list, it should be close to destination. If it is extended access list, it should be close to source. So you see, this is the router here, and it has one leg 0/0, and it has another leg 0/2. It has another one 0/1. So if it is extended, it will be close to the source, and the source here is the closest interface is G0/0. So that is where we are applying it. Okay. So you see, Correct. So we need to enter into the access, the interface. All right. So we will say interface fast Ethernet 0/0. Okay. We say IP access group. Oh, sorry. We need to enter the interface. Interface fast Ethernet 0/0. Okay, it's not fast Ethernet, it's gigabit Ethernet. Interface gigabit Ethernet 0/0. And then IP access group 100, and we say what? In, because it's going into the router. Okay. In. So that is it. So verify access list. So we're supposed to ping from PC1 to the server. If the pings are unsuccessful, verify the IP addresses before continuing. Okay. So we're supposed to ping from PC1 to server. So we're going to open this one, and then we're going to ping the server. This is the IP address of the server, which is this one here. So let's do it this way. Let's put it on simulation mode. Let's put it on simulation mode. Okay. So we're supposed to ping, where is it? 172.22.34. Ping 172.22.34.62, right? 62. Okay. So this is it. On a normal day, you should be able to go. We should be able to get the traffic. So let's see. It has gone to switch 1. From switch 1, it went to router 1. So this is where the access list is. Will it permit it or will it drop it? Okay, it has come to the PC. That means it didn't drop the traffic. It has done its verification. So it's going to go back. It's supposed to pass through. So it's not passing through. Let's see. Is it not passing through? Okay. Okay, so where is the activity? Okay, so it's still pinging. Let me see. Let's ping. Okay. So it's getting reply. So let's do it again. Let's do it again. Let's do it again. All right. So it goes to switch 1. And then goes to router. So now you see it has passed through without a problem. All right. Initially, the first one failed, but subsequently it allowed it to go. And the reason was because, there was no entry in there's what they call ARP, address resolution protocol. There was no entry in it to tell it which way to go. So now that we have done that, so it has gone and has come back safely. So correct. So now we are good. Okay. Now it also says FTP from PC1 to server, use the username and password, both are Cisco. So let's try and enter FTP. So, okay. We say FTP 172.22.34.62. Very good. Username, use Cisco. Password, Cisco. So you see, it has entered. So we are good on FTP. All right. So FTP is going. All right. So ping from PC1 to PC2, it should be unreachable. So let's ping PC2. This is the IP address 172.22.34.98. Ping 172.22.34.98. So destination unreachable. So it should be unreachable. All right. So we have finished that one. So we'll go to part 2. Configure, apply, and verify an extended named access list. So what we have done is the numbered access list. So we're going to do a named access list now. Okay. So a named access list starts with the IP keyword from the global configuration. So on router 1, enter the following command with a question mark. So you see, with a named access list, we start with the keyword IP, then access list. Okay. So I will say IP access list. So the next thing, if you put a question mark, it should ask you whether you want to do extended or standard. So our own will be what? Extended. If you ask a question, it will ask you for the name. So the name here, they say we should use HTTP only. All right. So that is the name we have to use. Okay. If you ask a question, you see this caret sign, meaning that that is all you need. All right. That is all you need. So let's see. Okay. So we press enter. Okay. Now, it says the prompt changes. Look at the prompt. This was what the prompt was like. Now it is changing to this. We're in extended access lists, and then it is a named access list. Okay. So let's see what happens. It says the prompt changes to this. All devices on PC2 LAN needs the TCP process to enter the TCP access. Enter the network address followed by the question mark. So we're going to permit TCP to this. Why are we using TCP? Because HTTP uses TCP. All right. So what is the wildcard mask? This is a /28. So you see the subnet mask is 240. So if you do 255 minus, look at it, 255 minus 240, what will it give us? Let's see. We say 255 minus 240, it will give us 15. Right. So let's enter permit TCP 172.22.34.96. Okay, the wildcard mask would be 0.0.0.15. Anyway, let's follow the activity gradually. Okay, so you see it, this is it, right? And then after that, then we put the destination, that is the server then. Okay, so this is the source. The destination now is going to be a host, right? And then 172.16, oh, sorry, 172.22.34.62, and then equals www. So remember we said we can use AT or www, right? Can use any of those. Now it says create a second access list to permit ICMP, which is ping, right? So we follow the same pattern. We say permit ICMP 172.22.34.96 with a wildcard 0.0.0.15. Taking it to host, that is the server, 172.22.34.62. Okay, good. So we have created that one. Then the next thing, if we do show access list, we should see all the 4 access lists now. Okay, if I do show access lists, sorry, need to exit. Show access lists. So you see, these are the 4. This is the one for FTP. This is the one for ICMP extended. This is the one for web. This is the second one for ICMP. So you see, these are all the 4 access lists we have created. So now the other thing to do is to apply it to an interface. So you see, our interest is this guy now. So which interface are we putting? This is the interface. So is it going to be in or out? That is where we are going to do it now. So go back to the global mode. I will say interface gigabit 0/1. Then IP access group. Then remember the name we created. You have to do it exactly as it is. Then say in, right? Once you do that, voila, we are done. We can even check our results. And you see, we have done it successfully. We have completed the activity. So that is how to create your access lists. You create your access list for the extended that we have done. Thank you very, very much. We have finally come to the end of module 4, which is access control lists. Okay. Tomorrow, the same time, tomorrow is Thursday, by 6, we are also going to meet again to look at module 5. Okay, we'll look at module 5. Hopefully by next week we'll be rounding up, and I'm hoping that by next week we should be able to cover up. But if we are unable to cover up, then you may have to complete the remaining yourself. Don't forget to do your assignments, your quizzes, your exams. Don't forget to do that. Any question? There's a question, let me know now. If there's none, then we call it a day. Any question?
Yeah, I think, I don't know, yesterday I know I left the class before Daniel was trying to show how to access the packet tracer.
Okay.
So I don't know whether you actually got that resolved with him.
Yes, yesterday we couldn't get it resolved, so I had to make some further inquiry by the headquarters. So I've gotten a solution for him now. If Daniel is around, Daniel, are you in? Daniel is not around. I would have showed him. The quickest way, there are two ways that will resolve that. When you want to log into the packet tracer, it shows you two accounts, net a card, and you see it blue. And the other one, you see skills for all, and you see it green. So what you just need to do is just click the skill for all and then log in into that. Then you will be fine. So I've reached out to Daniel and he said he's on transit now. The moment he arrives, he's going to reach out to me. So that's just the solution that will do that. Cisco says that they are having some small challenges with the caching of the application. So they are trying to work on it. So the quickest way is just to log in through the skills for all, and then you gain access.
Okay, do we all have access to the skill for all?
Yes, it's the same login credentials.
Okay.
It's the same
because I
login.
actually tried to download the packet that was giving me issue. It just, I don't know whether we might need, I don't know which one do you advise, because you actually sent two of the download files. One that is just a bulk file for the Windows, the Debian, and the Mac OS. Then there's another one again that you have it as individual packet tracers. I think for me, I don't know which one do we go for.
All right. Now, let me show you something. You can see this folder here has all the packet tracer activities that I have given you guys. The ones we just look at them here. These are the ones we just did now. All these activities, you are supposed to do them. They are packet tracer lab activities. But for you to be able to do them, you need to install the packet tracer. So if you check the link that I gave you where you can download the materials, don't go for the Mac. If you're using Windows, go for the Windows, download and install that packet tracer. If you do that, then automatically you will be able to open these applications here.
Good, because I did it and it's not actually opening this. Because I can see that your display is different. Mine is just showing just one bulk file. Even when I tried so, and it's not showing me individual file under it.
Okay, that is strange. Okay, 1 minute. Let me check something. But it should be coming just a minute. Okay. So now this is the drive where you guys will see. You see this packet tracer here. You see this is the installation file. You see packet tracer, this Windows. This is the installation file. If you download this, you should be able to install it on your system. Okay, yes. This is the installation file. Now, the activities that you are supposed to do, look at them here. See the activities.
Okay, so what you want us to do now is that after we install the packet tracer, they will now come and install each of the activities.
The activities, download them.
You can just download them again separately.
You can download all of them at once, or you download them separately. Okay?
Okay.
Yes. It's just a folder. This is just the folder. Let me see. I think you should be able to.
No, because okay, I don't know. Let me just get something clear, because yeah, if you install the packet tracer, there's nothing there.
Yeah, network defense materials.
Yeah.
So if you go to the folder, you should be able to select and download.
Okay. So okay, yeah. So if this we're doing two things. We will first install the packet tracer software for whatever OS system you're using before we come and install download these various folder into it again, because it needs to install for you to pick the folder.
Yes.
Okay. Yeah. Because I was thinking if we download if we install it to come with the folders.
No. Look at the folder here. You see under network defense, there is packet tracer software files.
Yes,
Lab activities. Now, software files here is where you are going to download. This is the Windows on. You are going to download it. But the lab activities, if you enter lab activities, can you see packet network defense packet tracers?
Yeah. I can see it. Yeah, I know where it. Yeah, I saw it there.
If you come here, just click download. It will just download the folder for you.
Okay, I get it now. I think that's the problem.
Download the folder. You will have all the material. Look at them here. Look all these files.
No, I can see them. No, I saw it, but I didn't know that we're going to do the two of them, one after the other. Yeah.
You need to do the two of them. First of all, you need to install the packet tracer for your operating system. Then you come and do these activities. And I bet if you follow the rudiments of this activity one after the other, you'll be able to be solid. It will enhance your skills in this class.
No, I can see it. I can see it. If that's why I'm so much interested. So I'll do that now.
All right. So that is very good.
Please, sir, can the link be shared again on the WhatsApp group so that we can get? I think when I joined, it has already been shared.
You see, I have given you guys, all you just need to do is go to the website. NCS, I've sent the website. Where is it? ncs.ncsplatform.org.ng. I will still post the website now again. And then you see, once you get here, come and let it load. Everything about the training is here. Once you get here, this is network defense. This is our schedule. This is where you see download class materials. If you just click here.
I see it. Yes. Okay.
Yes. If you say download class materials, if I click here, it's going to take me directly there. You see, it will bring you here automatically.
Thank you, sir.
But I'll still put even the class recordings. All right. Even the class recordings. Coming. Let me go back to the website. If you come here, if you want to access the recordings for the class, look at it here. Network defense class recording. For ethical hacking, this is the link. For network endpoint defense is the link. So if I come to network defense here, it will take me to the recordings that have been uploaded. So after this class now, the recording will be updated. So a moment. So you see, these are the recordings that we have done so far. Today's one is going to come up here. And remember, we said just always subscribe and then click the notification bell, because there are times that anytime we upload, if you miss the class, you need to get notified that a new video has been uploaded. So just click subscribe and click the notification bell, and then you'll be able to get it. All right. Any other question?
God bless you, sir. God bless you.
So thank you very much. I'm very happy you guys were able to make it to this class, even though the timing was not very okay for some of you. But thank you for being here. See you guys tomorrow. Good night.
Good night, sir.
Yes.
Thank you, sir.